So, Zahir, are you able to follow yesterday's class?
Yeah, I followed Sandeep, but I was not able to finish the last 15 minutes of the class. But other than that, I followed whatever you taught.
Okay,
Only
good.
the last 15 minutes I couldn't finish it.
Yeah. So, yeah, actually, day by day, the subject will increase exponentially like this for some more time.
Yeah.
So, are you facing any difficulties? I think it is now getting tough, at least a little bit.
Yeah.
So, yeah, you should solve some problems. That's why I gave that book. There is a book, right? So, live
Yes,
in.
Sandeep. Yes,
So,
Sandeep. I
yeah,
have a question.
sure. Yeah.
So in the book, if you could spend just a couple of minutes, how you want us to approach what chapters to start with.
You can start with confidence intervals. There is a chapter on estimation, right? I don't have the book right now here,
Okay.
but you can start with the estimation or confidence interval, whatever it is called there.
So the estimation is chapter 7. Sandeep.
Estimation is chapter 7. Yeah, you can start with that.
Okay.
So anything before that, whatever is the sampling distribution and all,
Okay.
I have did more than what they could cover.
Okay.
They did not cover all those simulations, all those things. So whatever I covered is more than what they can offer from the book.
Got it.
So even the test of hypothesis and confidence interval. So some of the things won't be there, like the table I gave you, the simplified one.
Yeah.
They'll give in a different way, but it will be more confusing. So don't go into the theory there. Directly
Okay.
go into the problem and solve it because you know enough actually.
Okay. Sandeep.
So one thing I wanted to mention, which is there in the book but not there in my notes, it is actually. So I was giving always sigma. Sorry, what is it? X minus mu by sigma. All those things, right?
Yeah.
So if you use x minus mu by sigma, this kind of formula, then sigma is the standard deviation. That you know anyway. But if you use, let's say, zcalc equal to x bar minus mu by sigma by root 10. This is from the sampling distribution, right?
Correct.
If you use this kind of a formula, there is something called standard error, and the standard error is defined as sigma by root n. Okay, it is nothing but the standard error is the error in the sampling distribution or the standard deviation in the sampling distribution.
Error in the standard deviation.
No error. There is no error in the standard deviation. It is more like how much is the deviance from the center in the sampling distribution, which will be the sampling distribution's standard deviation, right? How much is the deviation from the center, average deviation from the center in the sampling distribution? In sampling distribution, the variance V of x, I derived this, is nothing but sigma square by n.
Yeah.
I derived this. So in sampling distribution, the variance is this one. So the standard deviation is, instead of calling it as a standard deviation, they call it as a standard error.
Oh, okay.
Okay, that is in the sampling distribution. Okay, this works only in the sampling distribution. Sampling distribution. This is what I wanted to tell about the book. So in a if sometimes, so in the book, most of the times whatever we solved is like we solved all the problems from the data set. We calculated the average, we calculated the standard deviation, the number of samples, all those things we calculated from the book, from the data set. But in the book, what they'll give is, most of the times they'll give directly those values. What is x bar, what is sigma, all those things they'll give in the book directly, because they cannot give, because of their space issue. They cannot give every time all the data set, right?
Yeah.
So that will be the difference. Other than that, you will not face any problem, is what I think.
Okay.
If you face any problem, you can ask me. Okay.
Okay.
But don't do too many problems. So if you see our inferential statistics tree, this one, if you see this one, you'll understand. So what we are doing, estimation, confidence interval we have done. We are done with estimating mu, both on T distribution and Z distribution. Solve two problems for each of these. Z distribution 2 problems and T distribution 2 problems. And again, proportion estimation, again 2 problems. Chi-square estimation, the chi-square means the variance estimation, again 2 problems. If you solve like that, that is more than enough actually.
Okay.
You don't have to solve the entire book. I mean, if you're interested, you can do, but I'm just saying. Okay.
So I think I have just one more small question.
Yeah.
So in the example you did, at least the first problem after you solved it in the Coke dataset example, the curve we are drawing is for H0 and the regions we are marking for H1, correct? And
yes.
And since some of the Z distribution we used for confidence interval in the estimation process, can we sort of look at it in a similar way? Even though here in the test of hypothesis, you're looking at only one side of things, right?
You can do. I'll give that problem also. Today I planned for that problem. You're saying, can we do two-sided test?
Yeah.
Yeah, we can do that. That's why I planned for today.
Okay.
Okay. So yeah. Okay then. So let's take another problem. Let's start it as problem 3, right? So in the same test of hypothesis for mu, whatever we are doing is test of hypothesis for mu. We'll be doing the same thing for variance as well as the other one, which is the P0 proportion test. So what is the other problem? So here I tried to give some problem on the two-sided test. So let me give the problem. So every car, so this is for the automobile industry, car manufacturing. Okay, car manufacturing, what will it happen? How will it happen? So every car will have some kind of a metal, the metal body and the engine and all the other parts. So the metal body and the engine generally constitute for the most of the weight of the car. So what happens is, in every car, let's say car weight, let's say I am taking one model of a car, whichever model you want, and I know that this car can be around 4,000 pounds. It won't be exactly 4,000 pounds, but it will be more or less the same thing. Let's say that is my model that I am manufacturing. But this car, when I am manufacturing, there could be some or the other problems while I manufacture. Maybe the weight of the body, the metal body that I provide to the car, the metal body might be heavy in some cases because of the manufacturing deviations. One car might have more thickness of the metal body, other car might have lesser thickness. There are multiple variations, right? So, but on average, I want my car to be around 4,000 pounds, so that uh, so that it will be heavy enough. So in this case, the question is not it should be greater than 4,000 or it should be less than 4,000. So in this case, it is more or less I should have a car weight of 4,000 pounds on average. The reason for this is the more weight it is, the lesser fuel efficiency it will have, and also the other reason is my manufacturing cost will go up. So in both the cases, I should not have more weight. And the lesser weight, if I have lesser weight, then of course fuel efficiency will be good, but the problem is it is if it runs at a, let's say, 200 miles per hour or something like that, it might get easily some accidents or something. So car should not have lesser weight as well. If it is having lesser weight, then there is a more chance of getting accidents and all those things. So car should not be lightweight because of the safety reasons. And the other thing is, if metal is very lightweight, the metal that it has, then it is more or less there will be lesser safety as well, right? So the idea is that the car should be very closer to the 4,000 pounds. On average, it should be 4,000 pounds. That's what is my interest. So because I am manufacturing the car, I am giving that the standard deviation of the weight during the manufacturing. We know that the population standard deviation, because I am manufacturing the car, I know the population standard deviation as 250. And number of cars like that, I tested, let's say, 30 cars, and the X bar is the average weight. And the average weight of the sample, average weight of the sample, I found out to be, out of these 30 samples, I found out to be 3950. But what it is here, the 4,000 is on average for the population. This is what I'm expecting. But my X bar is only 3. For the sample that I collected, it is only 3950. Are you clear with this example? This is also pounds. Okay. Yeah.
Mu is 4,000 pounds.
This mu is not 4,000 pounds. This is what I wanted to test for. So I wanted to test. I want to have car weight equal to 4,000 pounds. But from whatever I collected, it is only 3950. So what I have to do, I have to test, is it really 4,000 pounds on average? See, from sample I got 3950. Okay, for the population I want to see overall, is it coming around 4,000 or not? Are you clear about it? These are two different things.
Yes.
This is what I expect it to be, but this is what I got.
Okay.
So what is? I'm sorry, I'm violating my own rule.
How did you get population standard deviations on them? Are you assuming or what?
Because I am manufacturing, right?
Yeah.
If I am manufacturing, I'll get the population data. That's how I get.
Okay, all right.
Okay, that's what I said. There will be some cases where sigma will be known.
Yeah.
So if there is a car model, only I have to manufacture, right? No one else will manufacture. If I am the manufacturer, I have to manufacture it. No one else will manufacture. So in those cases, you might get the population standard deviation. You might not. It's not always like only you will get sample standard deviation. Okay.
Yeah, okay, Sandeep.
Okay, let's see. So what is H1? Again, we have to frame the null hypothesis and alternate hypothesis always. So Zahir, can you tell what is H1? This is a little tricky, but you can get it, I think, from what I gave you.
So here, I'm thinking that mu needs to be equal to 4000.
Which is H1 or H0?
H1.
No. See, what is your motivation for collecting the data? If you expect that mu is equal to 4000, then there is no need to test it. So the H1 is always about why you need to test the hypothesis.
Okay, I think I get it. Yeah. Well, the reason here, either it could be greater than 4000 or it could be less than 4000. So there will be two conditions.
Yeah, instead of that, I can write it as mu not equal to 4000.
Yeah.
And the exact opposite again, the same thing, right? Mu equal to 4000 will be H0. So always think about why are you taking the pain in gathering all the data?
Okay.
If you are gathering, so to prove what? To prove that if it is equal or if it is not equal. If you believe that it is equal, there is no point in taking all this pain.
Yeah.
So that's how it is. So so we got this right. Now what is alpha? Alpha again we will define as 5%. We'll see if we can change it also. But that's fine. For now, let's keep it as alpha equal to 5%. Now what is it? The next thing is calculate z tab and z calc. Let's calculate z calc first.
Sandeep, your voice is breaking.
It's breaking. Abid, are you also getting the breaks?
Yeah, Sandeep, I am getting double voice.
Double voice. Let me disconnect and connect again.
Yeah, sure.